Okay, in class today, everything I did here was okay. Could have been a little more systematic about the way I listed things, but I did the transition matrix wrong. I just started looking at things sideways and got something, well, I got the transpose of the correct transition matrix. I knew eventually that's what I'd done, but at that point I needed to move on into other topics and said I would post a video. Okay, so here we are again. We have a stock market model, and the model says, okay, if the market is up today, then we say that there's a 60% chance it'll be up tomorrow, 25% chance it'll be the same tomorrow, 15% chance that it'll be down tomorrow. Now, I don't know if these are realistic probabilities. It depends on the market, and the market's a little bit crazy. So you can't really make a lot of conclusions here about what the market's going to do. And that's the nature of the market. And you can't predict it. But you can get some trends, and if you're really good, maybe you develop an instinct so you can succeed. I don't recommend it as a life plan, but if you play around with it and find that you're good at it, well, make your own decisions. Okay, well, anyhow, and I don't know that you really want to use Markov chains to do it. But again, learn a lot more mathematics before you ever try to do this. Okay, so before I try to apply it in a real world situation, especially something like the market. Okay, so anyhow, we've got these probabilities. Now, if it's the same today, we're going to say, well, 70% chance it's going to be down tomorrow, 20% chance it'll stay the same, and only 10% chance it'll go up. Now, I'm not sure these conditions are all that compatible with these conditions, but I've kind of made it intentionally a little bit weird. Okay, now, if the market's down today, we're going to assume there's a 80% chance it'll be the same tomorrow, 15% chance it'll be down tomorrow, and a 5% chance that it'll be up tomorrow. Of course, you can go into the market history and really figure out what these percentages have been over the last month, over the last year, over the last 10 years. Not sure what you do with it, and I sure wouldn't mess with it, but again, okay, so now, when I did the transition matrix, I didn't do it right, and my explanation probably wasn't right. This matrix, if multiplied by and I want to put down after up, but we're putting same in between up and down, which makes sense. If you multiply the matrix as I've outlined it here by the probability that was up on a given day, the probability it's the same, probability it's down, and you notice that these three probabilities have to add up to one. It's going to be one or the other. Also, I noted in the video that same means, let's say, it doesn't fluctuate more than 0.2% or something like that. It doesn't change by more than 0.2% up or down. Up means it changes by at least 2%. Down means it changes by, it goes down by at least 2%. Okay, now let's think about what happens. I multiply the probability that it's up by the probability that it'll be up if it was up the day before. Okay, so actually we'll get the probability tomorrow. If this is a probability today, then we're going to get the probabilities tomorrow. Yeah, I can't bring myself to follow up by anything but down, but it should be same. And down tomorrow. So this is the probability that it's going to be up tomorrow if it's up today. I multiply that by the probability that it's up today, and that contributes to the probability that it'll be up tomorrow. You might have to think about that a little. Then I multiply the probability that it was the same, that it's the same today, by the probability that's up tomorrow if it's same today, and I get another contribution to whether it's up tomorrow. And then I multiply the probability that it's up tomorrow if down today by the probability that it's down today, and I get another contribution to the probability that it's going to be up tomorrow. And then the other rows work the same. Now, if I put the numbers into this and do it carefully and correctly, which I didn't do last time, I was careful, it just wasn't correct. I've got to look back at the video to see what I was actually thinking. I was just looking at these and looking at them wrong. Okay. And it would have been better if I had written out a verbal description of what each of these things mean, so I would look at this correctly. Okay, so up if up. Well, it's up today, then there's a 60% chance it's up tomorrow, so that 60% chance goes here. Now, up if the same. Okay, well, here, it's the same. Okay, if it's the same, there's only a 10% chance that it's going to be up tomorrow. And that's what goes here. So it's a 10% chance. And then up if down. Okay, well, if down, then there's a 5% chance that it will be up tomorrow. Okay, now here, what's the probability it's same if it's up? Well, if it's up, there's a 25% chance that it'll be the same. Same if same, well, if it's the same, there's an 80% chance that it'll stay the same. And same if down, if it's down, there's an 80% chance that it'll be the same. And it looks like this is going to predict that, these probabilities are all high except this one. Predict a tendency toward being the same unless the market is up. Okay, down if up. So if it's up, 15% chance that it's down. If it's down, if the same, if it's the same, then there's a 70% chance that it's going to go down. And down, if it's down, then there's a 15% chance that it's going to go down. Now, I won't even speculate on what circumstances might lead to this or the implications. It's a lot to comprehend, although if you think about it, you can comprehend it. Okay, so now here's our transition matrix. Now, suppose that today model predicted, let's say, 30% chance that the market is up. And when I say today, we kind of know what today does. So let's say for some day, the model predicts a 30% chance that the market's up. %40 chance it's the same. And that would be same as, well, 40% chance that it'll be the same. And a 30% chance of down. Okay. The prediction for the next day, we multiply 0.6, 0.1, 0.05, 0.25, 0.8, 0.8, 0.15, 0.7, 0.15 by the column consisting of these probabilities of up, down, and same, up, same, and down. So it's going to be 0.3, 30% chance that it's up, 0.4, 40% chance it's the same, 0.3, 30% chance that it's down. All right. Now, where these probabilities came from, well, let's just say that there was a prediction made a week ago based on what the stocks actually were a week ago. And the prediction has evolved for the week to where probability on a certain day then is this. What's the probability it's going to be up tomorrow? What's the probability it's going to be the same? What's the probability it's going to be down? Well, 0.6 times 0.3 is 0.18. And that's the probability that if it really is up today, well, if the 30% chance hits, this is the probability that this is the number that contributes to the probability that it'll be up tomorrow. Now, there's a 40% chance that it's going to be the same today. And if it is, there's a 10% chance that it's going to be up tomorrow. 10% chance of 40% is 4%, or 0.04. And then if it's down, there's 30% chance that it's down. And if that's so, there's a 5% chance that it'll then go up. Well, 0.3 times 0.05 is 0.01. Sorry. Yeah, 0.015. And those are our numbers. And that's going to tell us the probability is going to be up tomorrow. Well, that's 18, 22, 23.5%. So it's looking like not a real good chance it's going to be up tomorrow. Okay, now let's multiply the second row, which gives us the probability it's going to be the same tomorrow. 30% chance that it's up tomorrow, and if so, there's a 25% chance it's going to stay the same. And that gives us 0.075, and then 0.8 times 0.4 is 0.32, and 0.8 times 0.32 is 0.24. And I hope I'm doing these numbers correctly. I'm sort of trying. That's 56% and 63.5. So there's a very good chance it's going to be the same tomorrow. Now, what's the chance it's going to be down tomorrow? Well, 15% of 0.3. You can think about what that means, but that's 0.045. 0.7 times 0.4 is 0.28. And this isn't working out real great. And that's going to give me more than 100%. And then 0.15 times 0.3 is 0.045. That's 928. That's 37. You can't have a 23% and a 63.5%, a 37% chance of three things. So something's still wrong. These numbers have to add up to 1. Now let's just check. This thing isn't, I still don't have it right. I don't know what's happening. The 0.6, the 0.25, the 0.15 add up to 1. Now this has to be a stochastic matrix, okay, because of the way these probabilities are set up. These three add up to 1. These three don't add up to 1. Something is amiss. And I'm not seeing what it is. So I'm going to pause this thing and ponder it until I figure it out. Okay, let's see. Pause. Okay, figured it out. And hopefully you noticed yourself. This number here should be same if same. And same if same is not 0.8. There's only 1.8 up here. I had 2.8s down here. Even commented on it. This should be 0.2. The probability that if it's the same today, it's going to be the same tomorrow. So I need a 0.2 here. And that's going to change this number. 0.2 multiplying this row by this column times 0.4 is 0.08. It's going to leave a smudge, but we'll live with it. Okay. And then I think everything else is the same because that's the only multiplication that involves this. And then that's going to change this probability. 24 and 8 is 32, and 7.5 is 39.5. This is the roughest board I've got. It's a little hard to write on. Combine that with my naturally bad handwriting. That does say 39.5. I'm not sure you can read it. And then if we add these up, 23 and a half and 39 and a half is 63, and add 37. Now that's 100%. And these should be expressed as decimals. So the three things that can happen tomorrow have to have probabilities that add up to 1 because something has to happen tomorrow. Something will happen tomorrow. The columns here, okay, probability is up if it's up, plus the probability is same if it's up, plus the probability if it's down if it's up, adds up to the probability that it'll be up. Or that it'll be something if it's up, okay? Because all these multiply the probability that it's up today. And if it's up today, then it's going to be either up, the same, or down. Probability is one of these things is going to happen with 100% chance, okay? Something is going to happen. Similarly for the other rows. And you want to read them through and think about that. And before you set up a model, you want to think it through that deeply and write out a bunch of words and make sure you've got it right like I did. Now, point is, if we then multiply this column by this matrix again, we're going to get the probability that on the next day, it's going to be up, down, or the same. And then we can multiply by the same thing again and get the next day, and we could predict 100 years in advance. Prediction wouldn't be worth anything because it's impossible to assign these probabilities with any reliability. We don't know what's going to happen tomorrow. We don't know what's going to happen in businesses. We don't know what's going to happen politically. We don't know what's going to happen. We don't know what the weather's going to do. too many things to influence the market. So I don't think these Markov models, at least at the superficial level, are going to give us any valid conclusions, although it's an extremely powerful method. And some people think that you can make reasonable predictions, at least a day in advance. Okay, so again, this is a stochastic matrix. It's a probability matrix, a transition probability matrix. The columns add up to 1, and the column vector that you multiply has numbers that add up to 1. They predict the probabilities of different outcomes tomorrow, given the outcomes today.